Can I erase this? So half-life is basically the amount of time it takes to cut like some mass in half, right? So like if I have like 64 grams is how much I end up with. Like after one half-life, I should end up with 32. Does that make sense? So like basically the amount, so if it took 1 day to, the half-life of some element is 1 day, and then like it took like took 1 day to cut it in half, so from 64 to 32. Then in 2 days, it'll cut the 32 and a half to 16. Does that make sense? Okay. So you should also, let me actually take a moment. You need to be able to calculate the concentration. You need to be able to derive the half-life equations. Sometimes he will might throw it. He threw it on my quiz. They're not that difficult. I'll show you how to do one right now, but then practice the others on your own time. Okay, so I'm gonna do it for the zero order. Okay, so for zero order reactions, this is deriving half-life. So I would practice deriving like all three, 0, first, and second. Okay. So half-life is the idea that, so for zero order, it's this A equals negative KT plus A naught, right? And so what you need to do is you need to make up numbers. So like what I did was like, if the initial concentration of A is, let's say A naught, that's the initial concentration of A, that means in one half-life, how much would I have left over? Half of that, right? So then 1/2 A naught. That makes sense? So then that means that if this is my A naught, this is going to be my A. So just plug those numbers in. So that I'm going to do A naught, so A is 1/2 A naught equals negative KT. And I'm going to write T 1/2 just to say that's the half-life, right? So I'm just specifying over here. Plus A naught, right? So then I'm going to subtract by A naught on both sides. So I should get half minus 1 is negative half equals negative KT 1/2. So I'm going to divide by negative K, divide by negative K, and I should get T 1/2 equals A. This is A naught 1/2, right? 1/2 A naught is A naught over 0, or 2, right? Then the negatives are going to cancel out, and then I'm going to put it over K. And if you look in that, like the first thing I drew, this is the equation for half-life, for a zero order reaction. Let me write it here. That makes sense? So then do that for any of the other ones, right? If you plug it into, you could do it for second order, you can do it for first order. For first order, you notice the 0.693, right? That's like natural log 1/2. So like if you like are doing this, right, and you're deriving a first order reaction, you get natural log 1/2. If you input that into the calculator, you'll get 0.693, which is why the equation says 0.693. Okay, so, alright, so going back, everybody understand how to derive? Solid. So, okay, so then now, how to deal with half-life problems, okay? So the simple thing is like, if I give you a K, an initial concentration, and I'm like, what's the half-life? That's kind of like plugging it into the equation, right? So if I tell you like something's a first order reaction, if I say this is a first order reaction, and this is like the equation for half-life, the most simplest problem you'll get is like, what's the half-life if K equals blank, right? You just plug it in and do it, right? The more difficult ones are, if it says, for this, it says, calculate how long it would take for 1,000 kilograms of limestone to be cut, to decrease to 1/64 of its size. and then it said that K equals 1.54 times 10 to the negative 4 days inverse. Okay? So that's more of the tougher problem, right? So, again, if you see a number like 64, you should not be like alarmed. You should be like, 64 looks familiar. Well, if I take 1/2 times 1/2 times 1/2 6 times, that should be 164, right? So if I do 1/2 to the 6th, that is 1/64, right? Now this is half-life, and this is the number of half-life. So if I said I'm going down to the 1/32nd of the amount, so if I went from 1,000 kilograms to 1/32nd of its amount, 1/32, then it'll be 5 half-lives. Does that make sense? Okay, so let me just show you how this would work if I had like 64, for example, and then after 1 half-life, I would have 32. After another half-life, I'll have 16. Then I'll have 8. Then I'll have 4. Then I'll have 2, and then 1. See how every single one is being cut in half? That's the idea of half-life. And so this is 1 half-life, this is 2, 3, 4, 5, 6. 1/64th of its size. That makes sense? Okay, going back to the problem, let's calculate how long it took for it to be cut 1/64th of its size. So again, I said how many half-lives did it go through if it's 1/64th? 6, right? Well, if we calculate the half-life if we calculate how long it took for 1 half-life, then we could just multiply that by 6, right? Because if I'm like, it took 1 day for this to happen, and so 1 day, the half-life of something is 1 day, and we went through 6 half-lives, then we went through 6 days. Does that make sense? So again, let's say this is a first order reaction. K is 1.54, so when I see first order, I should write down half-life, and I actually, just for habit, I should also write down this. I end up not using it, but I'm just gonna write it down just to habit, because every time I see first order, I'm gonna write both of them, okay? So, but I'm gonna use this one, so I'm gonna say T1/2 equals 0.693 over 1.54 times 10 to the negative 4. So this is going to be 4,500 days is the half-life, right? So if the half-life was 4,500 days, then I guess total time would be 4,500 days times 6, because I went through 6 half-lives, right? So it'd be 2.7 times 10 to the 4th, or 27,000 days. Does that make sense? Okay. So that's another way you can be asked about half-life, okay? One way is straight up like plug and chug, like here's K, find half-life. The other way is you'll be given a ratio. The other way is you'll be given a percentage, okay? So is everybody done with this? If you're not, like, yell, literally, I don't care. Okay, and notice we never even used 1,000 kilograms, right? Like, don't see the 1,000 and think you need to use it. Because sometimes he'll give you numbers and then you end up not using it. Does that make sense? So, just like, be able to tell what you need and what you don't need. Okay, the other way is the same situation. Let's say we have 1,000 kilograms. It's a first order reaction of limestone, and then it was degraded to 75% of its original size. So if it was degraded to 75% of its original size, it went from like 1,000 to 750 kilograms. Does that make sense? If I start with 1,000, I'm at 75% of its original size, then it's going to be 1,000. Or 750, sorry. Right? So I see first order, I'm going to write these two. Like, again, they're not all first order, but like, just for like the problems I'm doing, it happens to be first order. Negative kt plus natural log a naught, and then t1/2 equals 0.693. The reason why you write both is because you really don't know which way you're going to take, right? So if you notice, like before, when I went from 64 to 32 to 16 to whatever, let's say 8/4, right? This went from 100%, which is like full, that's what I started with, to 50% of its size, right? And this is 25%, and then so on, right? Notice 75% is nowhere here. That makes sense? I can't go half a half-life. Even if I went half a half-life, it wouldn't be 75%, it would be off. Because half-life is like I think it's a logarithm. So it's like, it doesn't work that way, but it does end up at 50% after one half-life. Does that make sense? So, we need a different method, right? There's actually two ways of doing this, okay? So, I'm going to do one way, and then we can do the other way too. So the one way of doing it is you can make up numbers, okay? So, if I started with 1 molarity, how much would I end up with? 0.75, right? If I started with 2, I'll end up with 1.5. If I started with 10, I'll end up with 7.5. It still works, right? No matter what number you plug in, it should work out, right? So that's one way of doing it, so then let's do that. So, and the question asks how long it took, so we're looking for t. And it said k from the previous problem was 1.54 times 10 to the negative 4 days inverse. So I go natural log, so I'm going to go natural log a equals negative kt plus natural log a naught. Then natural log a, which is, I said it was 0.75, because that's how much I ended up with, equals negative k, which is 1.54 times 10 to the negative 4 days inverse. T, which I'm looking for, natural log a naught, which I said was 1 molarity. Okay, so I get t equals 1.87 times 10 to the third, and the units are going to be days, right? Because those are my units for the rate constant. So like about 1900 days. That make sense? Okay. The other way you could have done it is you could have done one thing. You could have reorganized the equation, right? So it said 75%. So what percent of $1 is 3/4? 75%, right? So then basically the idea is like you need to set up a ratio. Well, one thing I could have done over here, so I could have just said, so I have, let's do it over here, sorry. So if I have natural log A equals negative kt plus natural log a naught, let's subtract the a naught to this side, equals negative kt, right? If I have two things subtracting in a logarithm, what does that mean? Division, so that I can go a over a naught equals negative kt. This is your final concentration divided by my original, right? So if I finally ended up with 0.75, I originally started with 1, right? So then like, this says 75%. This is the ratio you plug in the 75% here. So you just plug in, you can plug in 0.75 here. Does that make sense? So I don't know how he'll give you